My name is Kief. I've been with Thoughtworks about 9 years now, and my role is kind of around infrastructure engineering and dealing with cloud and platforms and these kind of things. When I joined, it was off the back of the continuous delivery book, which was just coming out at that point in time, and that really kind of clicked with me because I'd been working in the industry for, at that point, probably about 12 years or so, across roles in development and systems administration, and I was always kind of interested in that kind of in-between point. And the time that DevOps kind of emerged as a thing, and cloud was emerging and infrastructure as code was emerging, really kind of clicked with me, and the continuous delivery concept was great. And so what I would tend to do, my role on Thoughtworks projects when we go into clients was they were asking about, we want to do this continuous delivery thing, we want to make our release process more easy. And one of the keys to that was getting the environments consistent all the way through to production. And so what I and people like me would do on projects is kind of engage with the operations side of the organization, the people who are managing the infrastructure and environments, and say, what do we need to do in order to make this work more smoothly? How can we make environments more consistent? And by leveraging things like, so the time kind of Puppet and Chef were out, and tools like that, as well as cloud was just getting started, but not necessarily getting loads of adoption in the enterprise space at that point in time. So the thing was working with these people and trying to figure out how to make the best use of these technologies, because the technologies themselves weren't enough, right? So cloud was kind of the enabler, and still these days is an enabler for a lot of change. Organizations who are wanting to become digital, right? And the idea there, so a few years ago, what that meant was you would have a separate digital department. So you'd have organizations which were like, we want to do stuff online, and this is kind of a new thing, and they would set up a separate department that would be the digital team, the digital department, whatever. And what they would often do is say, we're going to use cloud because our existing IT department is just kind of obstructive, right? They get in the way, they're too slow, they're too old-fashioned. We're just going to go to the cloud and we're going to do whatever we want to do, however we want to do it, and not worry about all those old things. But then it turned out that wasn't, that a lot of the kind of things that those traditional operations teams were concerned about were actually things that did matter, right? Maybe the ways they were going about it weren't exploiting the new technologies and kind of aligned with new ways of working, but it's still a concern to think about things like security and managing of data responsibly and scaling and risk and all those kind of things are things we still need to care about. And then especially as digital started moving into the center of the business, it stopped becoming something that you can just keep off and run as this little kind of cowboy outfit off to the side and say that, well, real business is taking place now and growing on this platform. We have to take it more seriously. And also, we have to fold it into the whole business. The whole business has to kind of adopt this way of working and these ways of thinking and these new technologies. And so this whole thing of the risk and that kind of moving fast is a really kind of important concept. How many people are familiar with the State of the DevOps report, the Accelerate book? A fair number. I think this has been a really transformative thing in the world of DevOps over the past couple of years because they've done like research to find out about how organizations are working and what kind of outcomes they're getting with those practices. Whereas previously it was kind of like, we would be advocating to agile ways of working, DevOps and so on the basis of like it seemed like a good idea. From some of our experiences, it seemed to be more effective if you do it right. But this kind of puts numbers on it, it puts facts, right? So they looked at things about how effective, so first of all, the practices, right? So what kind of agile practices and techniques are organizations using? How are they organizing their teams, those kind of things? And then they also looked at outcomes, and by outcomes, they're looking at, as a business, what are the things that you have declared as your kind of objectives, and how well are you doing in meeting those, so whatever those might be. And it's not just the kind of technical things like delivering things, it's also a financial performance, even share price and those kind of things, and they're kind of building correlations between these things. And so the 4 metrics they found are the most indicative. So they measured lots of different things, but they found that these 4 are the things which kind of have the highest correlation to whether organizations perform well, what they call high-performing organizations, the one who achieve those objectives they're looking to achieve. And they found that there's kind of like these 4, you could kind of put them into 2 groups, right? There's throughput, which is around how frequently do you make deployments to your production systems, and then what's the lead time for making a change? Right? So it's like when you identify the need, whether it's like, oh, here's a bug we need to fix, or here's a new feature that we want to introduce, or here's a new product that we want to introduce, how long does it take for that to become into customers' hands, and we're starting to kind of find out how well that works, right? So those are kind of throughput indicators. And then there's the stability indicators, right? The change fail rate. How frequently, when we make one of those changes, those deploys to production, how frequently does it go wrong? Does it need to be remediated, either whether it's rolling it back or doing a quick fix or something of that nature? And then just generally, how quickly can you restore service if something does go wrong, if something falls over or whatever? How quickly can you get it back up and running? So these were the things they found for organizations where they measure these numbers. Positive kind of numbers on these correlate to overall success of the organization. And here's the interesting thing. I think instinctively, we kind of feel like we have to trade these off, right? Throughput or stability, right? We have to decide as an organization, are we going to focus on speed and sacrifice quality, right? We have, we're going to have to make that trade-off, or we're going to say, so that's like the startup mentality, the move fast and break things, right? Or we can choose to quality and have stability, in which case we have to sacrifice throughput and speed, right? That's the kind of, we think instinctively that these are things we have to trade off against one another. That this is, so you go, either you got the throughput's going to lead to instability, or stability is going to lead to poor throughput. So what they found actually in their research is that this is not a trade-off actually. So organizations that perform well against whatever metrics they're looking to kind of achieve as commercially are good at both of those things. And that actually organizations are not good at, you don't have that thing of organizations are good at one or the other. They're either good at both or bad at both. And I think this is kind of it makes a certain amount of sense when you think about it, in that basically if you're going to try to go fast, you can't do that if your systems is poor quality, right? Because things break and they slow you down, and you end up going slow anyways, and that's how you end up being bad at both, even though you tried to be good at the speed thing. And if you try to be good at the quality thing and say, we're going to go slow and careful, we're going to have lots of process, evaluate every change, and do things really, really kind of rigorously, you find that actually reduces quality as well, because it costs too much to make fixes to things. And so, yeah, you might, when you have something that kind of falls over and is a catastrophe, you stop everything and you go and you fix it. And often you do that by kind of breaking your process, right? When you have something that truly fails, you have to kind of abandon your process and do that kind of hot emergency fix. But that for the kind of routine things, to keep technical debt low and to keep this quality of the system high, if the barriers to making small fixes are very high, you have a lot of process involved, you won't do it as often. And so overall, you have a lot of technical debt, with long lists of known issues. And you see this a lot in kind of large financial organizations and so on, which are very focused on having heavyweight processes that they hope are going to make their systems higher quality. And when you actually go in there and look at kind of how they run things and the state of things, it's actually not that great. And so this is like Neil was referring earlier to the evolutionary architectures thing. And this is what we need to do with our infrastructure as well, right? And this is about saying, change isn't something that we can avoid. It's not something we can kind of minimize and limit in order to give us stability, because it doesn't help our quality, right? So we have to figure out how to exploit change, how to turn change into an advantage. So the goal here as an organization is to optimize for change. And by optimize for change, I don't mean just speed, that we have to figure out how to go as fast as possible, but also how to make changes reliable and easy and safe. So there are kind of three practices that I'm going to talk about today around doing this for our infrastructure. And one is obviously defining things as code. This is going to do some things that help us optimize for change. And then that's going to help us do continuous validation. It's going to help us make sure that we can kind of test each change and build quality into the system as we make changes. And then the third thing is making sure that we're building things in small pieces so that it's easier to do all of this. So for the first one, defining all of our things as code. This is kind of like the basic stuff of infrastructure as code, right? So we define all of our things as code so that it's visible. Everybody in the team and the organization can have a look at it and evaluate it. Auditors can come and have a look at it. It makes it easy to reuse things where that makes sense to do, and have consistency across things, and also it makes things testable. So some of the kind of, I guess, base pieces of doing infrastructure as code. The kind of enabler for this, the base thing is your infrastructure platform. You need some kind of a cloud. And it's going to have some resources, compute, storage, and networking of various kind of configurations of these things. And then you're going to take this and you're going to use your code to create stacks. All right? And so by a stack, what I mean is, how many people here are familiar or have used Terraform? Okay. How many CloudFormation? A little bit fewer. So this is kind of like, there's not like a common term across all of these tools, for like what is the unit that they work with, a Terraform project. CloudFormation does have a stack as a concept. But I kind of use the term stack generically just to have something to talk about patterns regardless of which tools you're using. You can use those tools, you can use Ansible, you can use Azure Resource Manager templates, you can, all those kind of things. It doesn't kind of matter at this level. We're talking about how to put these things to use in good ways. And so an infrastructure stack is a collection of infrastructure resources that we manage as a unit. So actually referring again to the evolutionary architecture book, they talk about a quantum of change, which is like what's the kind of piece that you can make changes to. And so if you change one thing in the stack, then you redeploy the stack, right? So that's why it's a unit of work. And then on top of this, on top of that kind of infrastructure platform and then the stacks that creates, you have application kind of runtime. Like what do you actually deploy your applications onto? So the common thing these days is virtual machines, your EC2 instances or what have you. You also, in many cases, you do it with physical hardware. So there's still organizations which have the need for the kind of performance to be able to deploy straight to metal, but that can still be automated and still be done in an infrastructure as code way, these kind of bare metal clouds and these kind of things. Container clusters are obviously becoming super common. So Kubernetes is the best known of this and getting the most traction, but there are other things like Nomad and so on. And then there's serverless runtimes, right? And so the kind of point of this is that all of these are different varieties of things that you might be deploying your applications onto, but you still want to have the kind of things around them. So to be able to kind of provision the thing itself, whether it's a cluster or what have you, you kind of want to do that as code. I'll talk a bit more about that later. And even for serverless, you're going to have things around it. So your serverless code, yeah, you don't have infrastructure necessarily that you're aware of or you have to manage. But it is going to have to connect with things. You're probably going to have network connections coming in, maybe out. It's going to have to store data somewhere. So there is still this kind of need to kind of define the things around it and to be able to test how this thing behaves in a non-production context before you deploy it into production. So all this stuff is still quite relevant. So this leads us to then how do we manage multiple environments with infrastructure? And there's a couple of kind of patterns that people do. So the kind of first thing, the kind of naive thing to do is to say, I've got Terraform, I'm going to create, I want to have a test environment, a production environment, maybe a stage environment. So I'm going to define this in a single project with like, here's my declaration of the code for each of these different environments, the servers in each environment. And it's a single Terraform project, a single stack. And so you do that. And the problem with this is the kind of blast radius of this stack, right? So if you're trying to make a change to testing, and you change the code for that to the test environment, change the code for that and apply it, you might accidentally break the production environment. There can be things that happen that have the unintended consequences across the environments. So most people who kind of try this out to start with find this as painful after a little while. So the next kind of thing that people do is to say, fine, I'm going to make a separate project for each of my environments. So I'm going to have separate code, and I'll copy the code from one environment to the next. And so this solves that problem of the blast radius. So now I'm going to make a change to my testing environment. I change just the code for that, run Terraform, and I'm not going to accidentally mess with any of my other environments, which is a good thing. But because you're making changes by saying I change the code to the test environment, and if I'm happy with it, I'm going to copy that code change to the next, and then copy it to the next. This creates the opportunity for errors, whether it's making a mistake in copying things, whether it's forgetting to kind of copy some part of it, or whether there's like variable, things that need to be changed in those environments for one or the other, like names and IDs and so on. This gets very messy, right? If you think about application code, it's not what you do with application code, right? You don't take your code base for your, say, Java application and then copy it to another GitHub repo for each environment and then copy, and paste code changes across for different environments. You have a single code base that you use. So for infrastructure, the equivalent of this is kind of like a template stack. And this is the idea you go back to a single project, but rather than that project containing separate code for each environment, this is like the code that defines an environment in a kind of abstract sense, right? So this is what my application's environment looks like. It has some application servers, some web servers, database, network rules, whatever it may be, and then you can apply that to one environment at a time. And so you can version it and you can promote it just as you would do with, say, a Java artifact. So that's kind of the groundwork then. We're defining stuff as code, and we're kind of able to kind of reuse it and promote it across environments. And so then the second kind of big thing that we want to do is to continuously validate. So we want to do automated testing and whatever kind of testing we need to do on our infrastructure itself, not just our application code, but our infrastructure code. So with this, every time you make change to your infrastructure code, whether it's your Terraform, CloudFormation, or or whether it's server level code, like Puppet, Chef, Ansible, you would like to be able to when you commit the change to source control, that tests are run on it automatically to give you feedback. Is it going to work as I expect? And then we can build a pipeline just as we have for applications for our infrastructure. And so we can promote it through our environments. And I'll go on in a moment to get to some of the more kind of complex patterns here, but the basic principle is this, that you promote your infrastructure code, ideally across the same environments that you have for your applications, so you're testing that it works before you put it into production. Now the big challenge with doing this, with testing infrastructure code, especially at that level of stuff that manages resources in the cloud, is that it takes a long time to run. Especially if you're creating network structures or so on, you're building servers and spinning them up. It can take 10, 20 minutes or more before you kind of find out, before it builds the environment, then you run the tests against it, and you find out, oh, I had a kind of fairly simple mistake that I need to kind of go back and fix. So this is where we get onto that kind of third core kind of practice for infrastructure as code, which is building things in small, independently releasable pieces, right? Components, what have you. And this is kind of going to the microservices kind of thing of saying, like, rather than having a monolithic infrastructure, we're going to have smaller pieces. So just to kind of think about it, we start out by saying we've got like a stack, right? So we've got our Terraform project, CloudFormation, what have you, that builds, like it's got some servers and some other things on it. And then we say, let's kind of pull out the code for what goes onto those servers. So if I've got installing a Tomcat application server and I need to have a Java installed, I'm going to write, say, in this example, we're using Chef cookbooks to do that. We want to kind of pull those out and test those first. We don't want to have to spin up the whole environment, say I'm building application servers and databases and networks, and then I'm going to find out whether or not I installed Java properly or configured Tomcat properly with my cookbook. Instead, you want to pull those out. So what you can do is kind of, you put this together at the kind of role level, and you say, we'll run tests. Each of these has got code that is independent, and we can test on its own. So we can test those things separately. We can say that we can test them actually on kind of virtual machines or even in containers. So there's tools like, say, Test Kitchen, which kind of orchestrates tests. What it'll do is it'll say, it'll set up the kind of environment, and it might use, again, a Docker image is a kind of good one because it's really fast with like a really pared down operating system on it. And then you say it spins that up and then applies the cookbook to install Java and Tomcat, runs a couple of tests to assert things. So there's kind of testing frameworks. I use a lot of things like RSpec-based things for this. So server spec, AW spec, InSpec is something that the Chef people have come out with lately that I quite like for this. And then that lets you kind of run it very kind of fast and orchestrates that for you. And then this is something that you can test locally on your own machine without having to spin up cloud resources. Also, it can run on your build agents, your kind of Go CD or Jenkins or what have you agents. And then you can kind of extract all these pieces out and create kind of more complex pipelines, but ones which kind of give you the faster feedback. They test at the lower level first, so it kind of, you start getting that kind of test pyramid effect of like, I can test server configuration very quickly, and then the things that I have to test when I actually spin up a bunch of servers, and then try to make, you might want to test like your network connections work all right across all of your subnets or what have you. And so those are things that kind of, they can come a bit later when you pull things together. You can also test, a really key thing is that we're to have testing the stack definitions. This is about testing like your Terraform code, actually building up the cloud stuff. You can pull those out and test those separately. And then the other kind of way of breaking your infrastructure apart into smaller pieces to make it easier to test and more practical to test is to kind of break the overall stack up. So I've been in a couple of clients recently where they have very large Terraform projects. I was at one where it takes about an hour to run Terraform on an environment because they've just grown over time and everything for their environment is in there. And so this is the same concept as moving from monolithic applications to microservices, is that we make it easier to kind of deal with if we can break it into smaller pieces like this. So each of these can be separate stacks, separate kind of Terraform projects that we then kind of integrate together in a more kind of loosely coupled way. So each stack has its own kind of pipeline. It's got, you define your contracts and pay attention to like where do things depend on each other across these stacks. And the trick in this, the kind of art or whatever to it, is working out where do we draw the boundaries between these different stacks. And the key kind of thing is different ways and different techniques, but it really comes down to optimizing for making changes to it. So what types of changes, the typical changes that you see in your teams, what parts of the system do they touch? And so if a type of change tends to kind of be, it touches like say some networking stuff and server configuration stuff or whatever it may be, you say let's put those together so that we can change those together rather than saying I have to change two different things and then try to coordinate those changes. Now, a couple of other things. So one other thing I mentioned, I was talking a little bit more about the container cluster thing, because this is something that's increasingly becoming an issue of, we're using Kubernetes clusters. How do we kind of manage that? How do we define it? And I think one of the kind of anti-patterns that people fall into is kind of they become snowflakes, right? So we think about continuous delivery for our applications. We're building containers and, into containers, microservices, and it's really nice. We kind of got these, but then our clusters that we're deploying them onto are basically snowflakes that somebody's built by hand, and then there's always the need to do like security updates and updates to the software and so on, and those can become very painful and very disruptive to the organization to say, we're going to do this upgrade now that's going to impact all the teams. We need to coordinate when is a good time to do it, and so what that means is that we do it less often. It's riskier to make those changes because when you change the cluster, you're going to change everything. You can potentially break everything that everything's working on. And so that makes more work to make that change happen, more coordination involved, and then it might be out of date. Or what tends to happen then is that your cluster configuration is out of date with you've got kind of known security vulnerabilities maybe there that you haven't had time to patch. Again, it kind of lowers the level of kind of quality of your system overall. So one kind of pattern to kind of deal with this is to break it down by the environments and say, let's have separate clusters for our production and for our non-production. In some cases, some teams take this to the extreme of saying we're going to have for every environment is going to have its own cluster. And this then kind of creates this kind of, it gives you testing, right? So if you're defining your cluster as code, your Kubernetes deployment and how that is set up is code and how nodes are built is all as code, that means you can apply those code changes in test environments. And ideally what you would do is probably have an environment before you even inflict it on development environments. So you'd have just I'm going to spin up just a test cluster that nobody else cares about except for the people who are maintaining the cluster code, and then run tests on it and make sure it's okay before you then roll that change out to development and test environments and then on to production, as all the kind of tests are, are run and everything is good. And so you have a pipeline for this, right? You have a pipeline for your infrastructure, for your cluster code as well. And then another way to kind of divide up this cluster is to say, let's do it by teams or by departments. And I think here, again, it's about kind of defining the boundaries based on change in ownership. So you really want, somebody who owns, a group of people who own an application or services to also be able to say, we have ownership over the infrastructure and the clusters and so on that those run on, even if there could be kind of governance and other people involved in making those changes, but it's not that we have to coordinate. Our department wants to make a change, another department isn't a good time for them, so we're going to have to wait and suffer for that. And so this avoids having to have big bang updates that roll out across everything. It lets you have different configurations for different teams, which can be very useful so you don't have those kind of battles or conflicts between teams. And it can also support governance boundaries. So you can say that, for instance, in terms of data, there might be some parts of your system which are handling data which has different regulations applying to it. And so you can say we can put that onto its own cluster and manage that separately so that other teams aren't kind of held back by regulations which may not apply to what they're doing. So the kind of big questions, a couple of questions on this. One is, where do we start? Do we build our thing first and then add the automation later? Or do we kind of build the automation in from the start? And this is kind of a difficult trade-off, right? But at the end of the day, so I think the issue with this is that doing the automation is a lot of work, right? So building automation for your infrastructure, building the tests, building pipelines and all that, it takes quite a considerable amount of work to get it going in the first place. And so what happens a lot of times is we'll start on a project and we start building this stuff out, and things aren't kind of moving as fast as people maybe thought it would because they'd underestimated how much all that was, and so they say, can we just leave the automation for later? And I think that the problem is that the automation itself is an enabler for speed, right? It's something that it helps you do experiments and it helps you kind of learn and test and prove that what you're doing is the right thing. It helps making changes. So building a system is a series of changes. So you kind of want to have a reliable way to make those changes as you're building. And so adding the automation afterwards, it tends not to happen, right? So people say, we'll go in. So how many people have tried to add unit tests to a code base, an existing code base that didn't have them? How many people have tried to do that? How many people found that really easy to do? Yeah, okay, one person, good. It tends to be really hard, right? It tends to be something that involves, if you actually end up doing it, you end up kind of rewriting a lot of your code in order to make it work because it affects the design, right? Having Just as with a unit test, which requires you to be able to kind of instantiate, say, an object or a small collection of objects, and independently on their own and run tests against it, the infrastructure is the same kind of thing. If you build this infrastructure as kind of this big thing of like we did the quick thing, we went and used the console or whatever to build it by hand, automating it is probably going to mean rebuilding it from scratch, so a significant amount more work. So the key here really is to do it incrementally, right? Is to say, let's not try to build all the automation for all the things first, but also let's not try to build the whole system first. What's the kind of quickest bit of value that we can deliver to our users and get into their hands? What's the kind of simplest thing that we can do to make that happen? And how can we kind of build the tooling just enough of that infrastructure and just enough of the kind of pipelines and tests to get that in so that you can then see some results. And so you see results, obviously, of the kind of code, the business value, the direct business value generating code, getting that into people's hands. You see, you start testing that. And also, like, how does our systems work? How does our automation work? And especially if it's not something that you've been doing up to this point, this level of automation, you start kind of working out, okay, what are good ways to do it? What works for us? What doesn't? And then that helps you kind of with the evolution of it.